Hello viewers, today's task will look at evaluating limits. So we have our first equation, which is number 1, which is saying evaluate the following. So for part 1, we have to evaluate the limit of 4 as x approaches a 2. So the limit of a constant number as x approaches any number, it is the constant itself. So here we're saying the limit of 4 as x approaches a 2, it will just be equal to a 4. That's one of the property for limits. Then now moving to part 2, we have the limit of that is 3x minus 4 as x approaches a 9. So for us to evaluate this limit, what we are going to do is, since we don't have a fraction, what we have it is a linear function, or a linear equation, a linear function to say. So whenever you have a linear equation, what you do is you just substitute direct. So the moment you substitute, you don't write the limit symbol because you're applying the limit, which is 9. So say 3 open, where there's x, you put a 9, then minus what, a 4. Then this one will give us 3 times 9, that's a 27. Then minus what, a 4. Then 27 minus 4, we have a 23 as the answer there. Moving to part 3. For part 3, we have the limit of open brackets. We have 3x squared minus 4x plus a 1 as x approaches to a 3. So that's what we have. So to evaluate this limit, what we have is a quadratic equation. We don't have any fraction. So for this one, we substitute direct as well. So there's x, we'll put a 3. So 3 open, 3 to the power 2 minus 4, where there's x, you substitute with a 3, then plus a 1. So this will give us a 3 open, then 3 to the power 2, that's a 9, minus 4 times a 3. So we can multiply 4 times 3, that's a 12. Then we have a plus 1 there. So 3 times 9, that's a 27, minus 12 plus a 1. So we have to subtract, that's 27 minus 12. This is 5, 1. So I have 15 plus 1, that's a 16. So the limit of that quadratic equation as x approaches a 3, we have a 16. So now we move to part 4. We now move to part 4. So part 4, what we have is the limit of that is x minus 4 over x squared minus x minus a 12 as x approaches a 4. That's the question that we have. So how do we evaluate this one? So whenever you have a limit of a fraction, you will test with the denominator. So get the denominator, which is x squared minus x minus 12. So now where there is x, we're going to substitute with a 4. Okay, because x is approaching to a 4. So where there is x, we'll put a 4. So it will be 4 squared minus, here we'll put a 4 minus a 12. Then 4 squared, that's 16, minus 4 minus a 12 there. So 16 minus 4, that's 16 minus 4, that's a 12. So 12 minus 12, which is a 0. So when you say the limit of that function as x approaches a 4, when you substitute with a 4, our denominator there, it will be equal to 0. So therefore this our function will be undefined. So if we have this, we need to factorize the denominator. So the denominator is x squared minus x minus 12. So we'll get the product, sum, and the factors. The product is negative 12, then the sum is negative 1. Then the factors, now we are going to use negative 4 and positive 3. So now we have x squared minus 4x plus 3x minus 12. So between these two numbers, you factor out x, which is common. then you have x minus 4. Here you factor out a positive and a 3, which is common, so you have x minus what? A 4. So here we have x minus 4, and that is x plus what? A 3. So now we're going to say this is now the limit as x approaches a 4. So I have x minus 4, that is over. Now that denominator, when factorized, we have x minus 4, and that is x plus what? A 3. So now we have the limit as x approaches a 4. So x minus 4 and x minus 4 cancels, we have 1, that is over x plus what? A 3. So now here we can now evaluate this limit. So what we're going to do, where there is x, now we'll substitute with a 4. So it will be 1, that is over, that is 4 plus what? A 3. So this will be 1 over what? A 7. So the limit of that fraction as x approaches a 4, we have a 1 over 7 as the answer. Then we move to part 5. So for part 5, what we have is the limit, that is the limit of 2 open brackets, we have negative, that is 3 plus x, then to the power 2 minus 18, that is over an x there as x approaches to a 0. So when you look at this our function that we have, we can see that our denominator there, it is x. So when we substitute with a 0, we are just testing with a denominator. Whenever you have a fraction, you just test with the denominator. So when you put a 0, the denominator will be 0. Remember, the denominator should never be equal to 0 whenever you have a fraction. So if it is equal to 0, meaning that it will be what? Undefined. That's what it means. So now, since we know it is undefined, we'll deal with the top part. We'll expand because we have negative 3 plus x to the power 2. So we expand that first. So meaning that now we have the limit as x approaches a 0. Then you're going to say 2 open, the negative 3 plus x to the power 2. This can be repeated twice. So it will be negative 3 plus what? X. Then negative 3 plus what? X. That's what it means. Then minus what? 18. So say I'll put this to mean that 2 will multiply with whatever you have inside the brackets. Then we're going to say over what? Over an x. So now we have the limit as x approaches a 0. Then now we have 2 open, then negative 3 times negative 3, that's a positive 9. Then negative 3 times positive x, we have a negative x. Then we have x times negative 3. This would be, let me do again. So here we are saying we have negative 3 times negative 3, that's a positive 9. Then negative 3 times positive x to be negative 3x. Then x times negative 3 to be negative 3x. Then x times x to be x squared. Minus what? That's an 18 there. So minus 18. Then we're going to say over an x. So now we have the limit as x approaches a 0. We have 2 open brackets. We have 9. Then negative 3x minus 3x. This will be negative 6x plus x squared minus what? 18. That is over what? An x there. So now we have the limit as x approaches a 0. We have 2 times 9, that's 18. You multiply. Then 2 times 6, that's negative 12. Then x. 2 times x squared, this would be 2x squared. That is minus 18 there. Then we're going to divide by an x there. So now here we can see that 18 can cancel with that negative 18. So now we have the limit as x approaches a 0. We have negative 12x. That is plus 2x squared. Then over what? An x there. So here what we're going to do, because we need to get rid of the x that we have down. So we're going to factor out an x on top. So we have the limit as x approaches a 0. We factor out an x, then we have negative 12 plus 2x. That's what we have there. Then we're going to divide this one by an x. So x and x cancels there. So now we can see that we have the limit as x approaches a 0. We have negative 12 plus that is 2x there. So now we can evaluate. Where there's x, we'll put a 0. So it will be negative 12 plus 2 open. This is a 0. So now we have negative what? Negative 12 as the answer. So that's what we do there. Then we have our party. That is party 6. So for party 6, what we have is that is the limit of x squared minus 9 over 3 minus x as x approaches a 3. So we need to evaluate this limit. So what we are going to do, test with the denominator, because now we have a fraction. So when we test with our denominator there, we can see that if you substitute with a 3 where there's x, you are going to get 3 minus 3, which will give us a 0. Remember, meaning that this our function will be undefined. So if it will be undefined, you factorize the top part, which is our numerator there. So on top, what we have is x squared minus 9. So to factorize this, we'll make the powers to be the same. So we have x squared, then 9 can be written as 3 to the power 2. So now this is difference of two squares. So this is x minus 3 and x plus what? A 3. So now we have the limit, that is as x approaches a 3. So on top, we are going to substitute with x minus what? 3. And also x plus 3, nothing has changed. Then we're going to say over, that is 3 minus x. So now we have the limit as x approaches a 3. We have x minus 3 and x plus a 3. That is over. Now we are going to start with a negative x plus a 3. I hope you're able to see what I'm trying to do. I want us to cancel the denominator with what we have on top. So now we have the limit, that is as x approaches a 3. Then on top we have x minus 3 and also x plus a 3 there. So down now we'll factor out a negative 1, so that now we have positive x minus 3. I'm sure now you can see that now x minus 3 and x minus 3 can now cancel. Then now we have the limit as x approaches a 3. This it will be now that is x plus a 3 over a negative 1, which will be now you are going to substitute. What is x? You put a 3, so it will be 3 plus what? 3 over a negative 1. So 3 plus 3 will be 6 over negative 1. So this will give us a negative 6 as the answer. So that's how you deal with that one. Then now next, our last question that we'll do will be that is part 8. So for part 8, what we have is we have that is the limit as x approaches a 0. We have the square root of that is 3x plus 1 minus 1. Then we're going to say over what? X there. So for this one, what we're going to do is, we can see that this is a fraction still. So what it is when you test with the denominator, you're going to get a 0. So meaning that this will be what? Undefined. So therefore, if now this will be undefined, you are going to rationalize the numerator here. So it will be now the limit as x approaches a 0. So we have the square root of that is 3x plus a 1 there, then minus a 1. Then we are going to divide by, so let me do this. So minus 1, that is over what? An x. So remember here, we are rationalizing the numerator. So we'll get the conjugate for the numerator, that is the square root of 3x plus 1, then minus 1 over the same, that is the square root of 3x plus 1, that is minus what? A 1 there. That's what we are going to do. So now this will give us the limit as x approaches a 0 there. So you start multiplying now. So you can see that now we have to multiply, that is root of 3x plus 1 times root of 3x plus 1. So that will be 3x plus 1. That's what we're getting. Then root of 3x plus 1 times negative 1, it will be negative over the root of 3x plus 1. That's what we're going to get. Then again, negative 1 times root of 3x plus 1. This will give us negative, that is root of 3x plus 1. The negative 1 times negative 1, it will be negative 1. Then we're going to divide this one by x times whatever we have, which is 3x plus 1 minus 1. That's what we have so far. So now it is now from this point where we are going to, on top you can see that, so when we are multiplying here on top, root of 3x plus 1 times root of 3x plus 1, we have this one which is positive. So this is what we have. In fact, when you are rationalizing, you get the conjugate for the numerator, of which I mentioned I didn't do that, so meaning that here you are adding. So now you have the limit as x approaches a 0. So now you multiply root of 3x plus 1 times root of 3x plus 1. It will be just 3x plus a 1 there. Then root of 3x plus 1 times 1, it will be positive what? Root of 3x plus 1. Then again, negative 1 times root of 3x plus 1, it will be negative root of what? 3x plus a 1. Then negative 1 times 1, this will be negative 1. Then we are going to say over, that is x open, then that is root of 3x plus 1 plus a 1. That's what we have there. Okay. Now from this point now, we can see that on top we can cancel root of 3x plus 1 and negative root of 3x plus 1. Then from here now you record what you have. You have the limit, that is as x approaches a 0. Then here we have 3x plus a 1, that is minus a 1. Then this will be over an x, open brackets. Then here we have 3x plus a 1 plus a 1 there. So this will be the limit as x approaches a 0. So on top we just have a 3x, because we know that 1 minus 1, it will give us what? A 0. So this will be over, that is x open brackets. Then we have the square root of 3x plus a 1. Okay, that's what we have. Then plus a 1 there. So now this one would be equal to the limit as x approaches a 1, a 0 there, as x approaches a 0. Then now we have, we can cancel this x and x that you have down, so that on top we just have 3 over, that is root of 3x plus a 1, then e plus a 1. So this now will give us the limit as x approaches to a 0 there. Now since now we have to apply these limits, so there's no need for us to write the limits. What we'll do is to just substitute. So while there's x here, we are going to put what? We are going to put a 0 there. So meaning that we have 3, that is over, then root of what is x, we are putting a 0, so plus 1, then plus a 1 there. So this will be 3 over root of 3 times 0, that would be a 0, so plus 1, then plus a 1 there. So this would be 3 over, that is root of 1 plus 1. This would be 1 over 1 plus 1, which is just equal to, that's a 3. So the answer will be equal to 3 over what? A 2. So root of, we have now the answer is 3 over 2. So that's how you deal with such there. The next now we move to part 9. I know we've skipped. I know we have skipped. That is part 7. That will be our last one. So now we move to part 9. So for part 9, what we have is the limit as t approaches a 4. Then we have what? That is 40 minus t squared. Then that is over 2 minus root of what? T. So this is what we have there. Now from this point now, we can now test with our denominator, and you can see that our denominator is 2 minus root of t. So there's t, when you put a 4, it will be root of 4. Then you have 2 minus 2, which is 0. So here we are getting our denominators in we are getting our denominator to be what? 0. So therefore, if we are getting our denominator 0, that means we need to rationalize the denominator this time around, because the square root is the denominator. So you rationalize the denominator. So now here we have the limit, that is as t approaches a 4. So we have that is 40 minus t squared, that is over 2 minus root of t. So we rationalize the denominator, so it will be 2, get the conjugate there, I change the sign, t, then over what? That is 2, okay? That would be 2 plus what? Root of t. That's what we have. Now from this point now, the next thing that we're going to do is you start multiplying. So you have the limit, that is as t approaches a 4. So you say 40 times the 2, that will be 8t. Then 40 times root of t, it will be just 4t. Then root of what? T there. Then t squared, which is negative t squared, times 2, it will be negative 2t squared. Then negative t squared times root of t, so it will be negative, that is t squared. Then we have root of t there. Then now everything, that is everything over 2 times 2, that's a 4. 2 times root of t, we have 2 root over t. Then negative root of t times 2, it will be negative 2 root of t. Negative root of t times root of t, it will be just equal to negative t. That's what we have. So now we just have to simplify this. We have the limit as t approaches a 4. So on top, what we're going to do is we maintain, we have 8t, that is plus before, okay, let's maintain. So 8t plus what? 40. Then we have root of t, then minus what? 2t squared minus what? That is t squared. Then we have root of t there. Then we're going to say now this one, that is over. We can see that down root of 2 root of t can cancel with negative 2 root of t. So down we just remain with that is 4 minus t. So here, even if you substitute, you still get the denominator equal to what? 0. That's what you're going to get. So therefore, what do you do? So on top, we're going to say we have the limit as t approaches a 4. So here on top, what you do is between these two numbers, you factor out what is common, and you can see that 40 is common on top. Okay, so we have a 40 that is common. Then we say open brackets. Then here we have a 2, because 80t divided by 40, we have a 2. then 40 root of t divided by that 40, it will be just root of what? T. Then here again we'll factor out what is common there. That's what we are going to do. So again we'll factor out what is common there. So now when we factor out what is common there, we can see that negative 2, not negative 2, what is common here, it is just negative t squared. So this will be open, then here we have a positive 2, then that is plus root of t. Then we're going to say this one now, that is over 4 minus t. So on top, we can see that whatever we have inside the brackets is just one and the same. So we'll say now we have the limit as t approaches 4. Then we have 2 plus what? Root of t. Then we are multiplying this with that is 40 minus t squared. Then we're going to say over what? 4 minus t. So I want us to cancel that 40 with what we have on top, n. So it will be now the limit as t approaches 4. Now we can see that this will give us I'll start with 4t minus what? T squared. Then we end with 2 plus that is root of what? T. That's what we have. Then here we are going to divide by what? 4 minus what? T. So now we have the limit as t approaches 4. Now here for the first part we're going to factor out we'll factor out what is common, which is a t. So when we factor out a t here, we remain with 4. We remain with what? We remain with 4 minus what? T. Okay, that's what we remain with. Then here we have that is 2 plus root of what? T. Then we are going to divide this one by what? 4 minus what? 4 minus a t there. That's what we are going to have. So now it is now from this point where we can cancel the 4. We can now cancel 4 minus t and what? 4 minus t there, so that we just have the limit as t approaches 4. We have t open, then we have 2 plus what? Root of a t. That's what we have. So now from this point now we have the limit. So now we can now substitute. Where there's t, we'll put a 4. So we have 4 open, then we have 2 plus the root of what? A 4 there. Where there's t, you're substituting. So you have 4 open, this is 2, then root of 4, that's a 2. So you can see that now we have 4 times a 4, which is equal to what? A 16. So that one becomes the answer for that our question that we have. Okay, then now we'll end with the question that I skipped. So now we are ending with our last question, that is part 7. So part 7, what we have is what we have for part 7 is the limit as x approaches 1. So we have a limit of x minus 1, that is over x to the power 3 minus 1. That's what we have. So now for us to evaluate this limit, we'll test with our denominator. So we can see that we have x to the power 3 minus 1. So when we substitute, where there is x, when you put a 1, it will be 1 to the power 3 minus 1. So 1 to the power 3 is 1 minus 1. This will be 0. So now since our denominator is 0, now we can factorize the what? The denominator. So I'll get the denominator. We have x to the power 3 minus 1. So there's a property that we use when you have a to the power 3 minus b to the power 3 there. This is the same as a minus what b. That's what it means. Then a squared plus a b plus what b, that is squared. So that's the property that we use. Now since we have x to the power 3 minus 1 can be written as 1 to the power 3. You've not changed anything. And now this will give us it is x there, you can see. Then b, it is 1. Ignore the sign there. So you say b, it is what? B, it is what? B, it is a 1 there. Then a, it is an x like I stated. So it is an x, so it has to be squared plus. Then a, it is an x. Then b, it is a positive 1. Ignore the negative. Then you're going to say plus. Then b, it is a 1. Then you're going to square that. So now this will be x minus 1. Okay. Then now we have x squared plus x times 1, x plus a 1. That's what we have. So meaning that we're trying to say x to the power 3 minus 1 to the power 3. This is equal to that. So you're getting this, the factorized one, and substitute here. So we have the limit as x approaches a 1. So we have x minus 1, that is now over. We have x minus 1, as you can see. Then that is x squared plus an x plus a 1. That's what we have. So we can see that x minus 1 and x minus 1 cancels. So we have the limit as x approaches a 1. As x approaches a 1, so on top we have a 1, that is over x squared plus what? X plus a 1. So now you are substituting. Where there is x, you put a 1, so it will be 1 to the power 2 here plus 1, then e plus 1. This is equal to 1 over 1 squared 1 plus c1 plus c1. So this will be 1 over 1 plus 1 plus 1, that's a 3. So therefore, the limit of that function as x approaches a 1, there we have our answer to be what? 1 over what? 1 over 3 there. So 1 over 3 becomes the answer.